Guys, the best way to study math is to do math. And that's going to require you to do a little bit outside of the classroom if you want to be successful. So hopefully somebody did. Kara?
Number 2 on page 3.
So page 3, these pages are numbered sort of. And number 2 says sketch it, list all of the stuff. So what's the first thing? It's like why? What's the first thing I'm going to do? Factor everything. So I have the difference of squares on the top and the bottom. Okay, nothing cancels, which means what? That's fine. There just won't be any holes in the picture. I don't have any of those. I do, however, have asymptotes and intercepts. So where are some of those things?
Horizontal is 1.
The horizontal asymptote is y equals 1. That's probably easiest to tell from the original problem because it's x squared over x squared. So that's my horizontal asymptote, okay? What else do I have? I have vertical asymptotes at 4 and -4 because those are the places where the fraction would be undefined, right? Can't have 0 in the bottom. And then the numerator tells me the x's that give me 0, so those would be my intercepts at -3 and 3, my x-intercepts at -3 and 3, straight from the numerator. And what about my y-intercept? What is it going to be? How do I find a y-intercept? Put 0 in for x. Okay, so do that. Staring at me isn't going to get it done. Plug in 0. 9/16, which is less than 1, right? So it's under here. Now, wait a second. That's it. Because we don't have any holes. I got all my intercepts, all my asymptotes. So now I have to figure out what it looks like. Usually, in fact, I think all the problems we have practiced, we've sort of been able to tell from what we've got. But if you're not sure, if you don't have enough to tell, you can always set up a T-chart and just start plugging in numbers, right? And get random points wherever to help you graph. But I think we've got it. What's happening in here in between the vertical asymptotes? Looks like we got a little parabola type thing. Mrs. Ford is not telling you that's a parabola. I'm telling you it's a parabola type thing. All right, what about the rest of the picture? The rest of the picture is up here. Not crossing an axis, not crossing an asymptote. It's up there and looks like that. Okay? All right, now what? What else? Who else found something? Good question. Who else found something? Page?
Number 6 on page 5.
Number 6 on page 5, number 6, says solve this system. Now, on some of the problems, it tells you specifically how to solve. Like it will say solve using Kramer's rule or solve with whatever. This one just says solve. So you can do whatever you want. So what might you do to solve this? Eliminate? Now, if you want to eliminate, absolutely you can, but the only thing you can eliminate would be the y's. because that's an x and that's an x squared, so those aren't going to eliminate. But you could certainly eliminate here, multiplying the bottom one by -2. So we have x plus 2y equals 1, and -2x squared minus 2y equals -4. Now the y's will disappear. What you have to be careful about is these don't add. So don't be doing anything weird with that. That's gonna be -2x squared, thank you, plus x equals -3. Right? Now, what's that? What do I do with that? This is quadratic, so it has to be equal to 0. And I've got a thing left over from when I was a freshman in high school. I don't deal well with leading coefficients that are negative, so I'm taking everything that way. You can do whatever you want. You gotta get it set equal to 0. I'm gonna move everything to that side so that my x squared is positive, because that works for me. Okay? Now, what do I do with it now? I've got everything moved. What do I do now? If it factors, I can factor it. If I don't want to factor it or it doesn't factor, I'll have to use the quadratic formula. I think this one factors. I think. Yeah. So what does that tell me? It does factor. What does that tell me? X is either 3/2 or X is -1. Now I'm not done though. What do I need to do now? Go plug them back in and find y, and I think I'll plug them in the top one so I don't have to mess around with squaring and stuff with the fraction. So it doesn't matter though. Kids, it does not matter. Plug it in wherever you want. Wherever you want. I'm gonna put 3/2 in here. If the fraction bothers me, I can multiply everything by 2. If it doesn't bother me, then I can just leave it. And then if I plug in -1, I think I get 1 for that one. So, let's solve the system. There we got it. 2 points of intersection. Okay? All right, what else? What else do we have to look at? Yeah. Same page, number 1. This is going to be a calculator problem, because we never learned how to do this by hand. So for this calculator problem, you'll have to write down a couple of things. You'll have to write down the matrix that you're going to put in and the matrix that's going to come out. Am I on the right problem? This is what we're going to do, right? So the matrix that's going in is 1, 2, 1, 7, 2, 1, -3, -5, and 1, -3, 1, -2. This is what's going in to the problem. Everybody good? Okay, now, I'm gonna put that in. I'm gonna press my RREF button, so you can write that down, so I know what you did. You press that button, and the new matrix is going to come out. This is the process of Gauss-Jordan reduction. We're just letting our calculator do all of the work. So we type in the matrix, second matrix edit, type it all in, quit, second matrix math, find that RREF. Second matrix, enter again. Did you guys get decimals? Okay, that's all right, I just wanted to make sure I didn't make a mistake typing in. Did you get, 0.68, is that what you got? Yeah. It is, okay, 1.8 and 2.72? It is totally possible, thank you, to get, fractions and decimals. I'm not concerned about that at all, I just wanted to make sure I didn't type a number in wrong. So does that look like what you got? Yeah. Okay, so, what's the answer to the question? Well, you know how up here, when we just did this last problem, our answer was x comma y? Because those were our variables. Well, our answer this time is gonna be x comma y comma z, and x is 0.68, y is 1.8, and z is 2.72. So there's the answer to the system. Okay? Amanda?
On that same page, can we do number 4?
Yeah, okay, got this, Kamara?
Yeah.
Okay. Number 4, evaluate. So we're gonna show our work. Now, when it says no calculator, that doesn't mean you can't use a calculator to help you with arithmetic if you've got big numbers. What it means is show the process of evaluating a determinant. Okay, now, I don't know if any of you guys ever work with kids with, that take this class with other teachers. There's more than one way to do this problem. And I know one of the teachers is doing this a different way, and it's fine, but don't get confused if you're working with someone else. The way I have asked you to do the problem, and I don't care what way you do it, I think this is the easiest. The easiest way, I think, to do the problem is to take these two columns and recopy them over here. Now, when you do that, guys, don't mix anything up. You don't change anything, don't switch anything. Literally, cut them out and paste them. Okay? And then we just start multiplying. So we multiply these three together, and notice I'm starting with my very first number. I'm multiplying those together, and I get 4. And then I multiply these together, and I get 0. And then I multiply these together, and I get -3. So all of that adds up to 1. Then I turn around, and I multiply these together, and I get -8. And these together, and I get 0. And these together, and I get 6. And all of that adds up to -2. And then what do I do with those two numbers? Subtract them. It's always 1 minus -2, so the answer to the problem is 3. All right? What else? What else? Come on, I'm ready to start chapter 9, which I'll do. If you don't have any
Number 9
questions.
on this.
This is your chance. Number 9, we're finding the area of the triangle. Okay, so first of all, the picture is totally irrelevant. If you're drawing a picture, great. If you're not drawing a picture, great. It's not necessary. Where you put A and B and C does not matter. What matters is that you create 2 directed distances, 2 vectors. So you're going to pick a point. It does not matter what point. Kendall, what point do you want to pick? A. If she picks point A, then she is going to find the directed distance from A to B. It's called a vector, that isn't important to you. The directed distance is. So that directed distance, the x's move from 1 to -1. How far is that, and is it a positive or a negative move? 1 to -1 is -2. And then the y's go from 2 to -3, which is a -5. So it's a distance 5 and it's a direction negative. Now, when Kendall picked point A, she locked herself into A, B, and A, C. You could have picked point B, but then you'd have locked into BA and BC. Okay, so AC is what? AC is, look at the X's, 1 to 3, and 2 to 0. Right? Be careful, get the right numbers. Now, simply take those numbers and make a determinant out of them. So -2, -5, 2, -2. Don't move anything around, just find the determinant. So just like here, we're gonna multiply here and get 4. We're gonna multiply here and get -10. And then what am I gonna do with those two numbers? Subtract. So that's gonna give me 14. And then remember to divide by 2. So the area of the triangle is actually 7. Also, it didn't happen to us, but sometimes when you do this determinant, it turns out negative. This could have come out to be -14. Don't worry about the negative, doesn't have anything to do with anything, just drop it. Think of this as absolute value, right? We're taking that area is positive. So your answer should always be positive. Drop the negative if you get a negative for the determinant value. Okay? All right, tomorrow? Okay, so the back of the last page, so the back of page 9. So the back of page 9, which one? Number 8. 8 says find the partial fractions. All right, what do we do to find partial fractions? It's the first thing we have to do. Factor the denominator. Don't mess with the numerator. I don't know, in this case we can do anything anyway, but don't mess with the numerator. You're gonna factor your denominator. So x plus 3 minus 2. Right? Then what? So we're gonna break it apart. Our job is to find the little fractions. So this is gonna be a fraction over x plus 3 and a fraction over x minus 2. And I don't know what those numerators are, so traditionally we call them A and B. Doesn't matter what you call them. Those are the numbers we have to figure out, right? Okay, so now what do? We get rid of the denominators by getting a common denominator. And isn't that the common denominator? Right? So if I want all the denominators to go away, I'll have to multiply by both of these things. And again, this, you don't have to show this work. What you have to show is what happens when you multiply. That's gone, so you're gonna have 9x plus 17 equal to what's left here? AX minus 2A, and then plus BX plus 3B. Now, this is an equation, right? So whatever x's I have over here have to match the x's that I have over here. So over here I have 9 of them, and over here I have a plus b of them. Now think about that. This is an equation. It doesn't make sense that whenever you add these two together, it has to be 9, like terms. And then similarly, 17 has to be the other two things, the negative 2a and the 3b. Well, what's that? A system of equations. Normally, these are like x's and y's, but it's the same thing. So what do we do here? We could eliminate, and that's what I'm gonna do. We could substitute, we could Kramer's rule, we could inverse method, you could do whatever, you know, you like to do. I know I love to eliminate, so I'm gonna multiply the top one by 2. And add them together, so 35 equals 5b, so it looks like b is 7. And if b is 7, then I can plug it back in, and a has to be 2. But that isn't the answer, and if you write that down in the answer blank, you're not gonna get full credit, because what was your job? What are you finding? The fractions. So the fractions are 2 over x plus 3. You have to put 2 over x plus 3, because when you set it up, you have a over x plus 3 plus b over x minus 2. There are your partial fractions. Okay, Van?
Can you do the first problem on the back of page 2?
Back of page 2, back of page 2, first problem, solve using the inverse method by hand. Alright, so first thing, let's make sure we're clear on is that right there exactly what I had right here? Yes, it's exactly the same thing. My goal here was figure out A and B, my goal here is figure out X and Y. Now, could I eliminate? Absolutely. Substitute, Kramer's rule, I have all those options. But here it tells me specifically, use the inverse method by hand. Now, it doesn't matter how you're doing the inverse method. Structurally, to do the inverse method, you take the inverse of the coefficient matrix and you multiply it by the constants. That's how you use the inverse method. So if I'm doing it on my calculator, I'm gonna have 2 matrices, I'm gonna put them in, I'm gonna do A inverse times B. I'm doing this by hand. So, what is my coefficient matrix? 1, 2, if I go across, it's 1, 2, and 3, -1. So I'm gonna have to take the inverse of that, times the constant matrix, and these are the constants, so the constant matrix is 8, 3. This is how I'm going to get my answer. Now the issue is I gotta do it by hand, which means I need to find my inverse. How do I find the inverse? That's what this means, the inverse. How do I find the inverse of that matrix? I find the determinant. So the determinant is -1 minus 6, -7. There's another part to it though. What else has to happen now? Make a new matrix by making some changes. And the changes are these two, so -1, 1. And these two change their signs, so they're gonna become negative. Then we take all these guys, this is our new matrix, and divide them all by -7. So I'll clean that up a little bit. That's +1/7, +2/7, +3/7, and -1/7. There's my inverse. Now, I need to take that inverse and times it by 8, 3. That's how the inverse method works. When it says, use the inverse method, you have to find the inverse and multiply it by your constants. So, what are the dimensions of this? 2 by 2. What are the dimensions of this? 2 by 1. When I multiply, I'm going to get another 2 by 1, and guess what? That's X and that's Y. And to multiply, I take this row of numbers times this column of numbers. So I take 1/7 and 2/7 times 8, 3. And I am not freaking out, folks. They have the same denominator. So this is like 8/7 plus 6/7, which is 14/7, which is 2. Now, if it didn't come out nice, I would just leave it, 18/7 or whatever it came out as. Then I'll take this row of numbers, 3/7, -1/7, times the same column. And that's 24/7 minus 3/7, which is 21/7 or 3. So the answer to the question is 2,3. If you eliminated, you would get exactly the same answer. If you substituted, you get exactly the same answer. So in this problem, the credit for the problem is obviously some of it's gonna be, do you have the right answer? But most of it's gonna be, are you doing the right process? All right, what else? What else, Paige?
On the back of page 4, number 4.
Back of page 4. Page 4, number 4, says multiply C times A. Before I get this all written out, can I multiply C times A? Is that even allowed? C, well, here I am writing it all out. What are the dimensions of C? 2 by 3, and A is 3 by 3, so I am gonna be able to multiply, so, okay. And the answer will be those math. The answer will be another 2 by 3. Okay. So when I multiply, I take row times column. So 2, 1, -3, that's my row. 1, 3, 1 is my column. Paige, this is very systematic. Now I just multiply them out, or multiply each pair and add, so what do I get? Looks like 0. Isn't that 0? Anyone paying attention? Is it 0?
Yeah.
Thank you. Now, I'll take same row, 2, 1, -3, same row, but now I'm gonna multiply it by this column. So that's gonna add up to, I think it adds up to 4, doesn't it?
Isn't the first one 2?
Oh, yeah, the negative.
2, 3, negative.
Oh wait, 2 and 3 is 5, minus 3 is 2, yeah.
Sorry about that.
Who agreed with me? Yeah, no, that's 2. Is the next one 4?
Yeah.
Okay, I took your word for it last time, I'm not doing it again.
No.
What's the, I got 4, did you?
Yeah.
Alright, first row, one more time, first row, this time last column, which is 2, 4, 3. That's gonna be 4 plus 4 is 8, that's gonna be -1. Alright, Paige, now I do the same thing on the bottom, I take 620 times all 3 columns again. So I do exactly the same thing, but this time I'm using these numbers. I got some papers to hand out, so you can go ahead and finish that one up. Get all these papers handed out here. All right, is that okay? All right, tomorrow's test day, we only have a couple minutes before the period's over. And,